Okay, so for this video we're talking a little about ti89 and its functions for statistical purposes. Okay, and so one of the questions I was asked the other day was about the Poisson distribution. And as you know, the Poisson is a discrete distribution. And so if we do a Poisson PDF, this, of course, is the fact that you're trying to do exactly that many. So exactly 6 or exactly 5 or whatever. If you're doing a CDF, by definition, it's always x is less than or equal to some bigger x, some x value. That's what CDFs always are. However, the calculators have been set up instead to do for a lower to an upper bound. So in theory, a person could always go from the lower to the upper bound. So you can do it either way. So, for instance, if you knew you expect, you get 3 defects per 200 items, then in 500 items, well, you'd expect 7.5, right? Which is simple to do one of these jobs. Little proportion, cross, multiply, and divide. There it is. Now, so if I asked you what's the probability that you get exactly 7 defects, of course it's going to be a PDF. And so bring up the calculator. So apps, and then mine's in a Flash app, but you're looking for stats list editor. F5. On PDF. He wants to know what you expect. I expect 15, and I'm asking him, or not 15, I'm expecting 7.5, and I'm asking about 7. So our answer is 14.6%. Okay. However, if I said I want to get no more than 7, well, that's another way of saying less than or equal to 7, right? So that's going to be a CDF. And so 7.5, that's true. My lower value, I'm going to put 0. My upper value, I'm going to put 7. So it's 52%. Hey, what if I said I wanted more than... No. What if I said I wanted at least 8? At least 8. Well, that's greater than or equal to 8. Now, in theory, a person should be able to do this. Come into here and go F5. And go from 8 to infinity. That's 1e99. No main area. You're like, why doesn't it work? I mean, it works with everything else we've done. Yeah, but not so fast. So now remember, this is equal to right? Because there is nothing between 7 and 8. These are discrete distributions. So we already know the probability it's less than or equal to 7 is 52%. So 1 minus that is 48%. Right? Ta-da! Now you can kind of fool the calculator by saying things like this. If you put in for its upper bound, if you put in like 1,000 or something, it'll give you a value 47.5%, which I think is actually closer to what it was, because I don't think this was exactly 52%. So it's like 52.5 or something. But that's the point. So you can kind of fool it on that. Pretty easy to do. Binomials are the same way. you want a binomial distribution on this thing. It's, you know, the probability that you get exactly 2 boys out of 3 kids. Okay. Well, it's PDF, of course. So in here, binomial PDF. We're talking about 3 kids. We're talking about probability of success is 0.5, and we're talking about getting 2 of them. So it's 37.5%. Okay. You know, some other things that we will do is chi-square distributions later on, and F distribution later on. Again, those are all located in the same place, F5. So I'll make videos more for them later on. T's and normals, we'll do those as well. Again, poisson right there. Geometric is here. Geometric is unfortunate. We don't get to do enough of that in this class. Just not enough time. Geometric is kind of a fun distribution to work with. So, hope that helps a little bit.